Hello, my name's Nick Taylor and I work for the Penwith Landscape Partnership. What I thought I would try to do today was explain a little bit about how Penwith was formed. This extraordinary landscape we see around us, what was the origin of it? So what we're going to do is we're going to go back in time 300 million years, back before the time of the dinosaurs. There are no humans around, obviously, 300 million years ago, and the surface of the earth looks quite different. The continents are in quite a different layout. Cornwall, or what was to become Cornwall, was at the bottom of an ocean. Either side of the ocean are two great land masses, one known as Gondwana land and one known as Laurasia, and these two continents are starting to move together, closing up the ocean, and they're moving by the action of plate tectonics. So the land that was to form Cornwall at the bottom of the sea was lots of layers of mud and silt and sand and all that kind of stuff you find in the ocean. This started to be squeezed, and if you can visualise, my hands being the continents and Cornwall being the book, gradually they got squeezed together and formed a range of mountains. This is known as an orogeny, a mountain building event. And what happens when you have land being pushed up is there's a space underneath. And so what happened was molten rock from deep in the earth flowed up underneath the mountains to fill the gap. And then, over hundreds of millions of years, the mountains have worn away. They've eroded to reveal the cooled rock underneath the mountains. The interesting thing is, if you travel down into the southwest, if you travel across Dartmoor, Bodmin Moor, Carmanellis, into Penwith, the Isles of Scilly, they're all made of the same stuff. So these are enormous bubbles of granite. They're called plutons. So a pluton is the word for an underground bubble of granite that has been revealed. And if you go down deeper, you find that they're all connected. They're connected into one large mass known as the Cornobian batholith. And that is the word for a deep, huge mass of subterranean rock. There's actually another mass out to sea, about 100 miles north off the northwest coast. There's another mass of granite about 30 metres down, known as the Hague Frass. It was only discovered in the 1960s, and that's made of the same stuff as well. You've got this series of big bubbles of granite. So Cornwall, when it was at the bottom of the sea, was made of mud and silt and all of that kind of stuff. As it was uplifted and pressed by the continents and the liquid magma, the original country rock, as it was known, was changed. It was metamorphosed, and that process of metamorphosing means that the heavy metals and other minerals coalesce in the same places, which is around the edge of the granite. So that's where you find all your tin mines. It's where the granite meets the metamorphic rock. So the big bubble pluton of Penwith is dotted with tin mines around the edge where it meets the metamorphic rock. So what's granite made up of? Well, originally it was a liquid from deep in the earth, but as it cools into a crystalline rock structure. So if you have a close look at some granite, what you'll see is it's made up of these lovely little crystals. It's quite difficult to see actually on a rock like this, because this rock is covered with various different types of life. You've got lichens, you've got mosses, you've got plants, so it's quite hard to see the difference between the lichens and the crystals. So you have to pick up a piece that's not been exposed to light. What you can see is that there are three basic types of crystal. The white ones that quite often stick out, those are quartz. The dark shiny ones, almost black shiny ones, those are mica. And then in between is a softer mineral known as feldspar, and that's the kind of pinky mineral that gives the Penwith cliffs their distinctive colour. Another interesting thing you can tell from looking at the crystal structure is what was going on as this rock cooled. Now, the granite at the edge of the Pluton cooled very quickly, and what that meant was the crystals were very small. But if you get very large crystals, like this one here, that means that this rock has cooled very slowly. So this was probably over millions of years, nearer the centre of the Pluton. Also, another interesting thing you can tell from looking at the crystals is whether the rock was flowing or whether it was stationary. So if the quartz crystals are lining up, that means that as the rock was cooling, it was flowing. But if the quartz crystals are all higgledy-piggledy in the granite, that means that the rock was stationary as it was cooling. Okay, so that's a little bit of an introduction to how Penwith got here. I hope that was interesting, and thanks for listening.